Hello everyone, so we have moved on to section 1.2, which focuses on line segments and then finding the distance between 2 points, or almost like finding the length of a segment. So we covered what a line was in section 1.1, and that is it's a bunch of points that are all in a row, right? But we know it's made up of at least 2 points, and those 2 points are what give it its direction. And we also know that it travels forever in opposite directions. And the final thing about a line is if we're trying to name it and we're using the correct annotation, remember we need that dash with the double arrows above it. So now we're going to look at what's called a segment. So think about how you use the word segment like in day-to-day scenarios, right? Like when a teacher says we're going to watch a segment of a movie, right? Or we're going to have a small little segment dedicated to geometry. They're talking about something that has a start and a stop. So a segment is almost like a piece of a line, but it has endpoints. So right here, notice that it does not keep going in these directions. It stops at point A and point B. So we name a segment just how we would a line with 2 points. However, notice the difference between these two. The difference being is the notation above the A and the B does not have any arrows. So that's how we can tell a difference between naming a line and naming a segment. Now, just like a line, I could have put segment BA, and that would be the same thing. So it doesn't have to, they don't have to be in a very specific order. That's not until we get to what's called a ray. So a big part of first semester is what's called segment addition. And the name literally describes what's happening. Segment addition. We are adding 2 segments together. So if we look at this diagram, we have 3 points, W, X, and Y. There's actually 3 segments here. There's segment WX, segment XY, and segment WY. So if we think about this, if I was to take the length of WX and the length of XY and add them together, so WX plus XY, that's going to give us the length of WY. So that is what we call segment addition, the process of adding 2 segments that are connected together. And if we just put that in a very simple context where we know the length of each segment, right? Segment EF plus segment FG equals EG. Segment AB plus segment BC equals segment AC. And then to find those actual numerical values, you just plug in the value of each segment. So what this means is segment EF is 2 3/4 inches. Segment FG is also 2 3/4 inches. So I would put 2 3/4 plus 2 3/4, and now it's going to equal the length of EG. So you could just add those together and get your length. The same thing is true over on the right. AB is 8.4, BC is 3.9, and whatever we get from adding those 2 together, that would be the length of AC. So that's segment addition. It's nothing very complicated. It's just the process of adding 2 segments together to get a bigger segment. Here's one kind of in a word format, or word problem format. It says find the value of A and the length of XY if Y is between X and Z and XY equals 3A, XZ equals 5A minus 4, and YZ equals 14. So pause the video right here and think about that for a second. So what we're going to want to do is make a diagram and just keep it simple. Now, I know I have 3 points on my line, or on my segment. I have X, Y, and Z. The only thing that we know is that X is between Y and Z. So I can put Y at the beginning of my segment, Z at the end, and I can just literally put X anywhere I want between those two. Now they then tell us that XY's length is 3A. So I'm going to draw in 3A. That's representing the length of XY. They tell us that XZ is 5A minus 4. And the last thing they tell us is that YZ is 14. Now let's think about our segment addition that we just talked about. This length plus this length equals the entire thing. So that means that YX plus XZ equals YZ. We then can take the amounts that represent those lengths and plug them in. 3A plus 5A minus 4 equals 14. And then we just use algebra. 3A plus 2A, 3A plus 5A is 8A. Add the 4 to both sides. That gets us 18. So that means A equals 18 divided by 8. If I was to reduce that, that would be 9 over 4. And then if I was to convert that to a fraction or to a decimal, that would be 2 1/4 or 2.25. Okay, so that means that that's what A's value is, one of those two variations. And then they asked us what the length of XY was. So we know that XY is represented as 3A, so you just take that value for A and plug it back in. So it'll be 3 times 2.25. And you guys can use a calculator to find that amount. All right, so that's another example of segment addition. This new word, congruent, it's going to be with us all year long. Whether we're talking about segments, whether we're talking about figures, all right? So what congruent means is it means two figures that are the exact same shape and size. Now, the symbol for congruence is an equal sign with a little enye above it, right? So, for example, let's say I had triangle ABC, that could be congruent to triangle XYZ. So that statement right there is telling us that triangle ABC is the exact same shape and size as triangle XYZ. So instead of saying same shape and size, we just use the word congruent. So triangle ABC is congruent to triangle XYZ. So for example, here now we have segment AB and segment CD. Well, segment AB is 17 centimeters long. Segment CD is also 17 centimeters long. So we don't really say when we're talking about shapes in geometry, we don't really say they're equal. We say they're congruent because we're talking about shape and size. So I would say segment AB is congruent to segment CD. All right, so that's a good example of how to use the word congruent. And again, we're going to use it for the rest of the year. Which brings us to the last part of 1.2, which talks about distance. So distance is a length of a segment from a point to endpoint to an endpoint, or the distance from one point to another. Now, distance can be calculated in two different ways. It can be calculated on a number line, but it also can be calculated on a coordinate plane, like an XY graph. Now, the way that we find distance or length differs a little bit between these two. So the one on the left, that's our number line. So you have to imagine when we're doing a number line distance, technically we could actually just count it out because it's a horizontal distance, all right? So if it's a small number line, my advice is just count the distance between the points out. However, once it gets to a larger thing, you might want to think about a different means. So for example, let's say I put a point at -4, and then I put a point at 3, and then I connected them to make a segment. Let's change the color up a little bit here. So if I said find the length of segment ST, so point S is at -4, point T is at 3. Well, you can just count it. 1, 2, 3, 4, 5, 6, 7. So ST segment is 7 units. But there's another way this can be done, and that is by using, whoops, let's go backwards here, went too far. What I can do is I can take the absolute value of the difference of these coordinates. So what I mean by that is my second coordinate, if I'm reading this left to right, is T. My first coordinate is S. So T's value is 3 on the number line. S's value on the number line is -4. I want to take the absolute value of the difference of those. So if I did 3 minus -4, that becomes 3 plus 4, and that gets me 7. Notice it's the same distance. Let's pick two different points. Let's pick -2 and 9. So I'm looking for the length of this purple segment here. Now I could count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But I could also just do my second value, which is 9, minus my first value. Take the absolute value of that. 9 plus 2. It's the exact same thing. All right. So you really only want to count, or excuse me, use this formula maybe if the points on the number line are spread super far apart. It really is up to you. Whatever you're most comfortable with. All right. Finally, we come to the distance between points on a coordinate plane. Now, this is where this gets a little bit tricky. Now, if you have points that make a nice horizontal segment, like this, you can just count those out. 1, 2, 3. If you have points that make a vertical segment, once again, you can just count those out as well. 1, 2, 1, 2, 3, etc. But the problem happens when you get a diagonal segment, right? How do I find the distance between those two? Because you can't count them like we were on the number line, and you can't count them how we were horizontally or vertically. That's when something comes into play called the distance formula. And so this formula is x2 minus x1 squared plus y2 minus y1 squared. Now that might seem a little bit confusing at first, but I promise you it's not. So let's label this A and B, and we're trying to find the distance from A to B. Now what these represent are the values of the x and y at point A and point B. So point A, if we look at our graph, is at -5, 3. Point B is at 5, 5. So this would be my x1, y1. This could be my x2, y2. Or this could be my x1, y1. This could be my x2, y2. It doesn't matter which ones you pick it, but whatever you decide, keep it the same. So this will be my 1s, and this will be my 2s. So what I'm talking about are these little numbers in the bottom, sub numbers. Okay? So again, I'm going to make this my 1, this my 2s. So my formula is x2 minus x1. Well, there's my x2, my x value for my second point. So that's going to be 5 minus x1. That's -5. So it's x2 minus x1, that whole value squared, plus y2, which is also 5, minus y1, which is 3, that value squared. So remember your PEMDAS, parentheses, exponents, multiplication, division, subtraction. Simplify what's inside the parentheses first. 5 minus negative 5 is 10. That's going to eventually get squared. 5 minus 3 is 2. That's going to get squared. 10 squared is 100. 2 squared is 4. So 100 plus 4 is the square root of 104. So now from there you can use a calculator to take the square root of 104. We can simplify the radical. We're not going to talk about that. But that is how you use the distance formula. Let's do it one more time without even a graph. So let's say I have the point 1, 2, and then I have the point negative 3, 7. And we're trying to find the distance of from x to y, or the length of segment xy. Here's my 1s, here's my 2s. X2 minus x1 squared plus y2 minus y1 squared. Simplify your parentheses first. Negative 3 minus 1 is negative 4. 7 minus 2 is 5. Negative 4 squared is 16. 5 squared is 25. 16 plus 25. 25 plus 10 is 35, plus 1 more is 41. So the distance from x to y is the square root of 41. Again, you can leave it like that. That you can't simplify, or you could get the decimal value by taking the square root in your calculator. So take a look over at the homework. It's going to be doing a lot of distance formula and stuff like that. Let me know if you have any questions.